So now we can move into a thing that's going to be a little bit important when you are out and about, and that is kind of understanding the coordinate system of the sky. And so there are kind of two basic coordinate systems. One of them is called right ascension and declination, and the other one's called altitude and azimuth. So there is a big difference between them. But the main difference is going to be that altitude azimuth is your location system of your actual position on Earth. So it's kind of very kind of you-centric, whereas right ascension and declination is kind of like it doesn't change for anybody else. And so if you tell somebody that this star is at a certain right ascension and declination, anybody else on Earth can look up that position as long as it's in the sky, of course, and be able to see that object that you're seeing. But if you were to report everyone or to everyone what your altitude and azimuth of something you see in the sky, without any other, like time or location or anything, it's kind of meaningless to do that. But if you're just trying to figure out how high above the sky or how high above the horizon something in the sky is supposed to be, that'll give you an altitude. So it gives you an idea of, is that object you're going to be looking at high enough for you to see it, and is it high enough for you to actually be able to see it well. And we'll talk about why that's an issue later. So if we switch over back to stellarium, you can actually see that right now I have right ascension and declination grid up already. So these steps right here, this is very kind of it's kind of the same thing as latitude on Earth. And so, like, the ladder, you kind of climb up the sky like this to the North Polar axis, and it always flips around like that, and then you get to Polaris. And so that is your latitude, or in this case, your declination. So right ascension is a little bit different. It's a little bit harder to understand. But basically, right ascension is these lines right here. So if you look at them, if we find this star right here, and we click on that, you see that it has a right ascension of 0 hours and 58 minutes. And you're like, okay, what does that tell me? Well, if we go over to this next one, it's 1 hour 58. If we go over to this one, pick something like right here, that is 23 hours and 59 minutes. And so that means this line right here is 0 hours. And you notice I'm talking about hours instead of degrees. So declination is numbers of degrees away from the north and away from the celestial equator. The celestial equator is 0. You can see that over on the side over here. That's actually out of the field of view there. So this one right here is 0 degrees declination. So you'll have positive declination this way, negative declination to the south. So you have to be sure when you're inputting stuff into your computer or into your telescope that you're using that positive or negative declination. Otherwise, if you put in a positive declination for something that's negative, you're going to be a completely different part of the sky. And you notice as we go up here to the north, spinning around just right, Polaris, or the North Polar axis, is 90 degrees. We can zoom in as much as we want, but this point right here is 90 degrees in declination. So that is degrees away from the equator, the celestial equator. But right ascension is different because it uses basically, if that line that we were looking at, let's try to find that again. I think it was somewhere in here. Yep, so that's 0 hours 8 minutes. So the position of this line was kind of invented by the Europeans, specifically some astronomers in Greenwich, England. And so they basically specified this line is 0 hours 0 minutes and 0 seconds when that position is above Greenwich, England on the vernal equinox. And so after that, if you go this way, every one of these big tick lines is an hour away from there in one direction or the other. But you can kind of see that if this is 0 hours 10 minutes, if you go backwards, this is 23. So that means it counts to the east from that point, and gets you higher and higher there. And so you can kind of count along these lines. And so if somebody's like, okay, I have this weird object, it is at 0 hours 15 minutes and positive 35 degrees, you can actually use this whole grid system to be able to like find it and look at that object. There are some objects that do move, like well, basically everything moves out there, but some of them moves on timescales that you can actually see, and these would be like comets or asteroids. And so you actually have to figure out what time of day and everything it's going to be and when you're going to be looking at it, because it has moved across the sky. But you can still use a right ascension and declination, but it's going to be a drifting right ascension and declination. And you notice that the star I clicked on isn't drifting at all in right ascension and declination, but your altitude and azimuth are. And you can see that that's here and that's there. That's because it's actually moving through your local side or through your local sky. So those are two of the more important things that you want to be able to understand when you're getting into astronomy and astrophotography and stuff. That way you can get an idea of where everything is, especially locally. So a couple other things that you need to know about these kind of stuff is you'll hear some terms called the nadir or the zenith. And if you come back to here, the zenith is going to be basically, let's switch this over to your local grid, your altitude and azimuth. Your zenith is going to be straight ahead. So if somebody's like, okay, we're going to look at something that's close to the zenith, Andromeda Galaxy is there, that means it's in a good position to be taking pictures of. If somebody's like, oh no, that's like way down to the nadir, that is directly under your feet. So if somebody says, yeah, look to your nadir and you'll be able to see it, well, they're probably trying to play a joke on you and trying to get you to look at your feet. So those are kind of a couple things that you want to deal with. So the azimuth grid, so the altitude grid is basically numbers of degrees from your horizon up to your zenith, and so it's 0 to 90. You won't have any negative numbers that's visible. Negative numbers will be what is not visible at your horizon. And if you're higher up on a mountain, you can actually see just a little bit farther down, because you can kind of see over the curvature of the Earth just a little bit. So you can actually do that in a way. So at a certain time of day, you zoom in right here and you see a star, let's say Cursa, right on the horizon. And then if you go up to a mountain that's like 10,000 feet high, you actually notice and you do it at the same time, but you have to take into account the star's rise 4 minutes earlier. So you'd have to look at this star 4 minutes earlier than you did the night before. But you'll actually notice there are actually more stars and stuff above or below that, and that's because you're able to look through the Earth's, or not through the Earth, but you can look around the Earth's curvature to see a little bit more because you're up higher. But that's only possible if you don't have any other things in the way of your sight. So if we look over here, so if you move over here to the north and look at some stars right there, you'll notice that the azimuth is 0. And so that means that this point directly north is your 0 point for azimuth. And so if we go over here, let's check this one out. That is 5 degrees, and 10 degrees, and 15. So this one is actually measured in degrees from north to the east, to the south, to the west, and then back to north. And it measures out 360 degrees. And so instead of using like right ascension, where it's an hour form, so there'd be 24 hours of right ascension, this is 360 degrees of azimuth, and also between 0 and 90 degrees altitude. So there's a little bit difference in how these things are set up. Okay, so that's kind of what we have to talk about with how the sky works, the positions of objects and stuff, and how those go, how time works, when you're talking about motions of the Earth and things like that. And so we kind of went over that. If you have any questions, feel free to put them in the comments. If I got anything wrong, feel free to bring it up and we can talk about that. But that should give you an idea of how things move through the sky, how to gauge where positions of stars are, how to do all this other stuff. And so that's why it's so important that you have on your telescope, there's a time that is important, your location that's important, and the time of day, and how you're moving and everything and where you are. So all of that stuff is important when you're trying to find stuff in the sky. And take pictures of them. So now we're going to switch over to talking about how the atmosphere and stuff actually can affect your being able to see stuff and take pictures of it. And so we're going to move to that real quick.